Good morning, everyone. Thank you for being here. My name is Jennie Korus, and I'm a part-time master's student in the Biological Oceanography Department, supervised by Dr. John Grant. I'm still in the proposal and planning stages of my project, so today I'll just be presenting some background and justification for the project, as well as my intended methods to be carried out. Focus of my project is to use biologgers to measure a physiological stress response in farmed Atlantic salmon, in response to some common farm occurrences, both environmental and operational. 5 minutes goes pretty quick, so I'll get right into it. To give you some context, I'll start by putting the aquaculture industry into perspective. Over the last 25 years, there has been a 75% increase in total fish production, but the amount being produced by aquaculture has skyrocketed over this period. In 2018, it made up for 46% of total fish production, but actually supplied 52% of the fish for human consumption. As our planet's population continues to grow exponentially, there is a significant need to invest in sustainable food production, and aquaculture is poised to meet some of this demand as it's currently the fastest growing food sector. If we look at Atlantic salmon specifically, we continue to see sustained growth in production year over year. Salmon is a highly sought after, high value product that is becoming more affordable for regular consumption by the average person. As this industry continues to expand, the welfare of these animals is being brought to the forefront as a concern to consumers. So it's important that we address these concerns with data and scientific studies. On farms, methods to characterize stress in fish typically involves measuring effects at the tertiary stress response level. This includes measuring growth rates, immune response, and observing changes in swimming behavior. The problem is that these effects typically represent a delayed response to a stressor, and so they don't allow farmers to identify the initial cause of stress, and this prevents them from implementing any mitigation strategies. Advancements in technology have allowed for the increased ability to monitor animals in situ. Fish tags or biologgers can be used to monitor heart rate, temperature, acceleration, and depth of fish as they experience regular aquaculture practices and adverse water quality conditions. Environmental sensors that monitor dissolved oxygen, temperature, and depth can also be used to capture fine-scale changes in water quality within individual pens and provide that data to farmers in real time. I am hopeful that the combination of these sensors can be used to help characterize an earlier stress response to adverse water quality or farm operations and enable farmers to identify stress in their livestock earlier. I am planning on tagging 20 Atlantic salmon with Star Audi data storage tags that collect heart rate, acceleration, depth, and temperature in a single pen on an aquaculture farm here in Nova Scotia. In the same pen, 20 Novasi environmental sensors will be deployed measuring oxygen, temperature, and depth. The plan is to target 3 4-week intervals where high frequency data will be collected to capture the fish's response to common stressors. The first is low dissolved oxygen conditions that are typically prevalent in late summer due to higher water temperatures. The second is in the winter when the surface ocean temperatures can drop below negative 0.7 degrees, which is the temperature at which fish's blood can freeze, and this is more commonly known as super chill. The third data collection period will target some kind of farm procedure to capture operations that can be inherently stressful to fish. Whether this is some kind of handling or transport or lice treatment is still undecided, but will likely depend on the specific farm operations at the time of data collection. This research has 2 main objectives and will answer the following questions to address specific gaps that currently exist in the available literature. First, what is the stress response and the severity of the response measured by heart rate, temperature, and swimming activity to some common events on aquaculture farms? And second, can this combination of environmental and physiological sensors characterize a general stress response that can then identify other farm stressors sooner? This data could be used as a baseline to justify the development of more advanced monitoring mechanisms on farms that can help guide day-to-day operations and inform decision-making to provide a higher standard of care on aquaculture farms. Thank you.